So now we'll look at the paramagnetism, right? So this is very easy. So paramagnetic materials, they do not show all these aggressive property like a ferromagnetic substance, and also they do not show the repulsion like any organic substance like a diamagnetic substance, right? So in the previous class we have understood why one diamagnetic substance basically repel the magnet, right? Now here in the paramagnetic substance, we know that like in the like p orbital or s orbital, whatever, if we have the unpaired electrons, right? For example, the electrons feel in this way. In the last class I showed you, so this electron basically is indicating the unpaired electron, right? So this electron is unpaired electron. Now this unpaired electron, you know that for the unpaired electron, if we observe the path of the unpaired electron, this is basically constitute a current. So if this constitute a current, so this current will eventually behave as a magnet, a tiny magnet, right? And which tiny magnet has a north pole and also a south pole, right? It behaves like a tiny magnet, but it is not a magnet. But if in terms of the magnetic field lines, if you observe, then magnetic field lines will go in this way, right? Magnetic field lines will go in this way, right? This is the direction of the magnetic field lines, and it will come outside from the north pole and it is go inside in the south pole like a normal magnet, right? Normal piece of magnet. So this unpaired electron, the path of the unpaired electron, this will produce a current I. This current I is very tiny, but also this is producing some amount of current I in terms of like microampere, and this current will produce some amount of magnetic field. And this magnetic field, when this magnetic field exposed in the actual external magnetic field, for example, there is a bar magnet we have, and this bar magnet, this is the north pole and the south pole, and we are drawing the magnetic field lines of this bar magnet, right? Now what we are doing here, we can see that there is a let's say for example there is some amount of oxygen gas, and oxygen has the unpaired electrons, we know that. So due to these unpaired electrons, the each and every oxygen atom, they are behaving like a tiny magnet, right? So let's say for example here we have tiny magnets, right? For example let me draw a couple of magnets here, right? And all the magnets basically, this all the magnets, their orientation is random, okay? Their orientation is not regular, they're randomly oriented, all right? So if their orientation is random, then let's say for example there are some amount of oxygen gas is there, and inside of the oxygen gas there are all the oxygen atom, they are basically behaving as a tiny magnet, and this tiny magnet has a north pole, south pole, north pole, south pole, north pole, south pole, north pole, south pole, south pole, north pole, south pole, north pole, north pole, south pole, and south pole, north pole. These are the random thing we can expect. Now whenever this oxygen gas is now exposed inside of any external magnetic field, then what are the things that you can expect to happen? You'll be able to see that all the south poles of these tiny magnets, they will be getting attracted towards the north pole or the external magnetic field, right? Am I right? Yes. So in the very next scene, you can expect that in this north pole of this magnet, sorry I'm sorry, the north pole of this magnet, right, it will attract all these tiny little dipole, sorry, all the tiny little magnet towards itself, right? So all these dipoles, all these magnets will be getting attracted, and this side will be south pole definitely, right? South pole, south pole, south pole, and these are the north pole, north pole, north pole, north pole, north pole, and north pole. Alright, so you can see that this there will be an attraction force between the unpaired electrons producing magnetic field, unpaired electron producing magnets with the magnetic field or external magnetic field. So there we can experience attraction force, and this attraction for any unpaired electronic substance with the magnetic field or with the external magnetic field, we can name it the paramagnetism. Or these substances like oxygen in gas or liquid nitrogen or any kind of stuff would not have the solid state, but in the liquid state or the gaseous state, they are called the paramagnetic substance. Although we have one list of paramagnetic substance, so we cannot randomly call any gaseous substance or any liquid substance a paramagnetic, because we have a list of item inside of the paramagnetic materials. But most of the cases, the unpaired electrons with the liquid or the gaseous state basically shows the paramagnetism. Now you can ask me, you have all the rights to ask me, why the liquid and the gases? Because the mutual, the cohesive force of the liquid and the gases are not that strong enough to prevent to go all these tiny little magnet towards the external magnetic field. So the cohesive force is very small when we are talking about the gaseous or the liquid state, right? So this is basically the idea of the paramagnetism. Okay, so in the next class we'll be discussing about the ferromagnetism.